How's it going? Let's get into the week 12, day 2 homework and see how this one goes. This is the one that's about law of sines, so I actually think it's easier than the previous day. Day 1, man, that was kind of a nightmare. That video is an hour long, an hour. And granted, I'm trying to explain some stuff deeply, but still, man, it takes a while. Let's get into this. As it says here, I am going to mix in some law of cosine problems. So I'll try to discuss how you know whether you want the law of cosines versus the law of sines. Let's go. 37 says we're surveying a canyon. It says there's two markers A and B on the same side of a canyon rim. They're 56 feet apart. That's all labeled. A third marker C is located across the rim, positioned so that the measure of BAC, that's this guy, is 72. And ABC, that's this guy, is 53. So it says find the distance between C and A. I'm not sure why that's what you want, but mark that as X. We're after that. And it says also find the distance between the two canyon rims, assume they're parallel. Well, distance between two parallel lines should be measured along a perpendicular. So we know that essentially what we're finding is the height of this triangle. So I would redraw this whole thing. That's the sharper angle. Yeah, so zoop. Yeah, that's terrible. Let me start again. So we're looking at basically this. We've got a 72-degree angle here. That's A. We've got a 53-degree angle over here at B. That's C. We know that we're after X, and we know that we're after the height, which is dropping straight down from vertex C. So call that H for height. Okay. So what have we got? We've got two angles and a side down here, sorry. We know the 56. So we've got two angles and a side. So what we have is a SA, because we've got the angle in the middle. But the deal is when you have ASA, that's two angles. And we talked about how you can always find your third angle. So if we wanted this angle up here, then we kind of also have angle side if we want it. We sort of always have both. If you have two angles, then you have all three angles. So let's do that math, find the measure of angle C. We know the measure of angle C will be 180 minus the sum of the other two, 53 and 72, which is what, 125? So that'll leave 55. So the measure of angle C, I've got it at 55. Now that is the whole angle. So the 55 is not split by the height. It's the whole angle, angle C. Okay, why is that important? Well, it is important because we know that we can really only use the law of sines when we've got both angle A and side A, or angle B and side B. But in either case, we know that what we need is we need a known angle and a known side opposite from it. And I didn't have that until we found angle C, because we may have known angle B, but we didn't know the side opposite from it. We may have known angle A, but we didn't know the side opposite from it. And we did know this side, but we didn't know this angle until we found it. But we can always find it once you've got two. So those pink things, the 55-degree angle on the side whose length is 56, that's what allows us to use the law of sines, because I can fill in both parts of this ratio, and then I'll be able to fill in one part of the other ratio. If I want side X, then I can plug in angle 53. So we know this angle, which means the only variable left is B, and we can solve for it. Okay, so that's the idea. So I know I can use law of sines. So I'm going to plug in the angle, divide by the side, plug in the angle, divide to find B. So the pink parts, we've got the 55-degree angle and the 56 unit long side. And then the green parts, we've got the 53-degree angle, and we want to solve for x. So there's your setup. From here, the math's pretty easy. You cross multiply and you get an answer. So cross multiplying gives me x times the sine of 55. 56 sine 53. So to solve for x, we're going to be dividing by that sine of 55. That cancels, and we see that x will be approximately whatever this gives us. So we do sine 56, we do 56 times the sine of 53 divided by the sine of 55. So in our calculators, you're just hitting those buttons. 56 sine 53, is that right? Divided by sine 55, yep. And you can just plug it all in like that and hit enter. So 54.597. And again, since this is supposed to be modeling a real world application, you do want to include units in your answer. These are feet. Okay, but now we also wanted this height. And to find that height is a piece of cake, because that height, when it drops down, it carves out of this triangle a right triangle. So we don't need the law of sines or the law of cosines for this. We can use regular old basic right triangle trigonometry. If you pull out that right triangle, we're after this height. We know this angle is 72 degrees, and we just found x. It was 54.597. So going back to geometry, that should be the first time you learn this. Opposite from 72 is h. The hypotenuse is 54.597. So we know there's a trig function that we can use to link these two sides. So given SOHCAHTOA as a mnemonic device, we know that of sine, cosine, and tangent, the trigonometric function that involves opposite and hypotenuse is sine, of course. So we can set up an equation where the sine of 72 is equal to the height of the triangle divided by the hypotenuse, which is 54.597. So we just multiply both sides by 54.597 and we get our answer. So h is going to be 54.597 times the sine of 72. So h equals, okay, again, a little bit of calculator savviness. Get in your calculator, notice that answer, that, this value, it's still sitting in your calculator waiting for you. So literally just type times so that you get the answer, and then type in the sine of 72. And in this way, you haven't lost any accuracy whatsoever. You're using the full decimal expansion of that previous answer. You're not just using the 3 that we rounded it off to before. So in this way, you'll get 51.925. I mentioned in the last video, if we don't do that, if we use the 54.597 that we rounded off, then we'll be off by a little bit. And usually that's not that big of a deal. Yeah, in this case, it's not a big deal at all. Either way, we had 51.925. Down here, I get 51.925 because I am rounding it up. You can see that we are off by a couple thousandths, but we'd still be keying the same answer into the computer. We're both going to get the same answer. I mentioned, again, in the last video, that where this matters more is with inverse trig. Inverse trig can be really sensitive. So imagine we got some long decimal by doing like 578 divided by 2,459, who cares? But you get some long thing. If I do second inverse sine of the answer, I'm going to do tangent. I think actually tangent is the most sensitive one. But if I do the entire decimal expansion, bladao, I get this. If I, however, did inverse tangent of just the rounded off decimal, the 0.235, Not crap. Okay, whatever. We're only off by 0.003. But just trust me. You try to be as accurate as you can all the time. Just out of curiosity, would sine have proved my point better if we did inverse sine of the entire decimal versus the inverse sine of the rounded 0.235? Bah, no. Okay, whatever. Trust me anyway. I don't care. Moving on. Boink. All right. The heck was the actual answer? I pushed it all the way off my screen. I don't even remember anymore. Hold on, I'll find it. 51.925. And those are feet. And that's number one for you. So from here, we go to number two. Where's my cursor? All right, so this one is about weather forecasting. Almost literally the exact same. If you look at the previous problem, what did we have? We had an angle, a side, and an angle. This is the same. The only problem is the angles we have are sort of on the outside of our triangle, because if you read the question, it says the meteorologist at point A cites a tornado that's 38 degrees east of north. So they're giving us this angle, which lives outside of our triangle, which is fine. It says that points A and B are an east-west road. So we know that this thing is essentially horizontal. The north is perfectly vertical. So that means this entire thing is 90 degrees. So we know that this angle here is just the complement of 38, meaning they're complementary, meaning I subtract from 90 and I get 52. Oh, yeah, that was cool. Putting the 2 like it's a degree sign, 52 degrees. Do the same thing here. The 53 subtracted from 90 to find the complement, you get 37. And so those will be the angles inside of our triangle. And then what are we doing? It says the meteorologist point B cites find the distance from each meteorologist to the tornado. Also find the distance from, okay, super awesome. So great. We want to solve for A. The meteorologist at point A. Well, that's a little bit annoying. So the distance from the, what is this thing? A tornado. I mean, really, we should be calling this point T, in my opinion. And then it's also kind of annoying that the distance from meteorologist A to the tornado is called B. I would call it A. And I know that flies in the face of our normal convention of naming the opposite side by the lowercase letter. But I don't know. I'm going to fly in the face of it. I think I want the distance from scientist A or meteorologist A to the tornado to be called A, and the distance from meteorologist B to the tornado to be called B. So I'm going to take some liberties here. Get mad at me if you want. I don't care. Anyway, let's do it. I'm saying I don't care a lot. I do care. I care a little. B. B is going to be purple. So how do you solve for that? Well, pretty sure that I don't want to use law of cosines. So let's see. I've got an angle, it's supposed to be purple. I've got this purple angle, and I do not have the opposite side. That's bad. That's a bad start for us. I've got this green angle, just 37, but I don't know the opposite side, so that's bad for us. And then I've got this side down here. That's good, but oh, no, I don't have the opposite angle. But wait, we said that anytime you've got two angles, you got the third angle too. We can find that angle for free. So do that immediately. We know that the measure of angle T is going to be 180 minus the sum of the other two, 52 and 37. So that's going to be 180 minus 89. So that's going to be 91. Okay, so cool. That means now that in my sine ratios, oops, can't do that, totally wrong. Sine of side A divided by A is supposed to equal the sine of B divided by B. So again, the A and the A are supposed to be opposite pairs. B and B are opposite pairs. So I wrote 90, hi Chihuahua. All right, now I need my orange highlighter back. Then I need to actually write 91. Okay, but whatever. So our numerator is going to be the sine of 91 divided by the opposite side, which is 25. So there's our fully filled in ratio, which I know I can set equal to the next ratio. If I know the angle, I can find the side. If I know the side, I can find the angle, okay? And I know the angle, and I want the side. Let's solve for A first, just because, you know, the alphabet. We'll put 37 in here and solve for A. We solve by cross multiplication. So it's going to be A sine 91 equals 25 sine 37. Just to mention this really fast, sine 91, think about it. Where's 91? It's barely beyond the y-axis, right? And sine is our y value. So if the y-axis is the point 0, 1, you already know that the sine of 91 is almost exactly 1, like it's super close to 1. So when we get this answer and divide by sine 91, we shouldn't see it change by very much. So I'm just going to kind of mention that, point that out again. Sine 91. So what's 25 sine 37? 15.045. So now if we divide through by sine 91, don't expect things to change by a hell of a lot. And the reason why they won't is because sine 91 is so close to 1. So we should be finding that A is the number in my calculator divided by the sine of 91. Oh, look, it's still 15.04, but it's 0476 now, so 8. So just don't freak out when that changes by so little. The reason it didn't change is because that was so close to 1. Now what are my units here? Miles. So this has to be miles. So that's A. We now find B in basically the exact same way, literally down to even using the same orange ratio that we used before, the 90 sine 91 over 25. But where we set the orange ratio equal to the green, this time we'll set the orange ratio equal to the purple. So we're still going to go sine 91 divided by 25, but we're going to set that equal now to the sine of the angle that's opposite from side B, 52, and divide that by B. And I don't actually want this gray. Why? So we'll turn it black. Okay, but cross multiply. And again, you guys should probably be in a place in your lives where you can do the bulk of this in your head. We're going to multiply by B, and it'll be B times the sine of 91. So you know that B will equal 25 times the sine of 52. And then you'll be dividing by sine 91, just like before. And just feel free to enter that whole mess in your calculator. 25 sine 52 divided by sine 91. 19.703. Okay. So there is one more thing we're supposed to find, and that's the height of the triangle. And to find the height of the triangle, you could use either one of these right triangles. You've sort of got the orange one over here on the left that has the 52-degree acute angle. Excuse me while my pen behaves oddly. Or you've got the blue triangle on the right that's got the 37-degree acute angle in it. We could use either one because if we go orange, we know side A, so we could solve for H using a sine ratio. If we use the blue, well, we already know B, so we could solve for the height using a sine ratio. Either way, it's a sine ratio. I'm going to use B. So we know that the sine of 37 has to equal the opposite side divided by the hypotenuse. So within the blue right triangle, the opposite side is h, the height, and the hypotenuse is side b, which we just calculated to be 19.703. So now just cross multiply, and 19.703, which by the way should be the number that's still sitting in our calculator right now, just needs to get multiplied by the sine of 37 to give us our height. So just press times sine 37. And that'll give you 11.857723, which runs to 11.858. And I forgot my units. These are still miles. Miles. These are miles. Miles. Okay. So that's it for that one. There. Okay, that's a ridiculous thing to care about, but I care about it. Next, this one says Surveyors Calculations. It says Tony must find the distance from point A to B. So he's trying to find the distance across this lake. So if he has no boat, that's going to be hard for him. He locates point C, that is 860 feet from A and 175 feet from B, and he measures the angle at C to be 78. So find the distance AB. Okay, cool. So looking at this problem, I've only got one angle, so I can't solve for any other angles. And that's problematic because I've got the angle, but I don't have the side. And then I've got a side, but I don't have an angle. And then I've got a side, but I don't have an angle. So the fact that we have no known pair of angle to side tells me that this is the problem that I slipped in. That is not a law of sines problem. This is your law of cosines problem. You don't have enough information to solve by law of sines. So remember I warned you about that? There's going to be a law of sines problem mixed in. Now, if you're super smart, if you're like Sherlock Holmes, you might have noticed this was number 38. And then whoopsies, this was 38 again, because it came from a different problem set. So if you notice that clue, pat yourself on the back. But anyway, so we know that to solve this problem, we got to use law of cosines. By the way, the other clue was this is SAS. The given information is SAS, which we already talked at length about the fact that that's a given, that you got to use law of cosines. Look at the other problem. It was ASA. And with ASA, we can use law of sines. So let's solve this thing. We know that to solve for D, we put the D all alone on the left. We set it equal to our side squared, 860 squared, 175 squared, minus 2 times 860 times 175 times the cosine of our angle, 78. And I happen to have written a program in my calculator to do this for me, so I'm not showing the work. If you don't know how to do log cosines, go back to the day 1 video and watch that. So what's our answer? Bonk, bonk. 860, 175, and 78. According to my calculator, the answer is 841.216 feet. And I'm getting 216 because it's really 2155,378, just in case you wondered. Okay, hey, can you do this? No, you really shouldn't. If you were doing this, you would be showing me a lot more work, justifying how you got from there to there. I'm just being lazy bones. Moving on. All right, problem about a balloon. Direct between the okay. So we had a question about a balloon on the classwork where the balloon was tied at point A and the wind sort of blew it over like that. That's not what this one is. This balloon's not tied anywhere. There's just an observer at point A who's observing the balloon with an angle of elevation of 28 degrees. We talked about angles of depression. There's obviously going to also be angles of elevation. So imagine a mountain overlooking a body of water. And I don't know, some dude is down here on the water surfing. Here's his little surfboard. And he's surfing. Look at him go. No waves, but he's surfing anyway. So what's an angle of depression? The angle of depression from the top of the mountain down to the surfer would be you establish that horizontal line and then you measure down from there. That's an angle of depression. But by the same token, maybe there's like a bald eagle up here. And the bald eagle is looking down at the surfer, really respecting his sense of freedom. And there's an angle of elevation from the surfer up to the bald eagle. And guess how that works? You still just establish a horizontal line. But instead of rotating down, an angle of elevation rotates up. So this angle here is your angle of elevation. This angle here is your angle of depression. And anybody who knows geometry reasonably well will remember that a horizontal line is parallel to any other horizontal line. And then this sight line between the bald eagle and the surfer is acting like a third line that in geometry you called a transversal. And so from there you might remember that there's a whole bunch of special angle pairs here. You had corresponding angles, alternate interiors, alternate exteriors, blah, 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 blah. Well, your angle of depression and your angle of elevation are alternate interior angles. So they'll always be congruent, okay? Your angle of depression and your angle of elevation between the same two people or birds or whatever, they'll always be congruent. And I mention all that, not because it's relevant to this problem, but because maybe it'll be relevant to future problems. So anyway, 28 degrees is the angle of elevation from person A, but person B, who's closer to the balloon, has a greater angle of elevation of 37. The distance between them is 2.32. This is another ASA problem. So you're going to do it exactly the same way that we did the first two. And what that means is, what are we finding? Finding the altitude of the balloon. Okay, so to find the altitude of the balloon, we'd love to do that right triangle stuff, but we don't have enough information yet, because if we want to find that opposite side, we would need to know the adjacent side or the hypotenuse, and we're going to find the hypotenuse. So I'll call this, what do I do? Do I call it A because it's the distance away from person A? Or do I call it B because it's opposite from B? Let's go back to calling it B. Doesn't much matter. Hopefully we know that to solve for B, we would set up a ratio where the sine of the 37 degrees is getting divided by B. And then by the law of sines, we would set that equal to the sine of some other angle divided by its opposite side. Problem is we know the 28, but we don't know the side opposite from that. We know this, but we don't know the angle. Okay, I got to stop doing this. You guys should know this by now. We've got two angles. You can find the third. So assuming that's an angle called angle C, we know that we can find angle C by doing the same old 180 minus 28 and 37. $65. So 115. So that's going to be the pair of parts that we use. We're going to use the 115 degree angle located at point C, which is opposite from side AB, which is 2.32. And then you cross multiply to solve. So cross multiplication says that B will equal 2.32 times sine 37. Sorry. And then remember, the B gets multiplied by the sine 115. So to solve for B, we would divide sine 115 on both sides. So basically, just don't even show it. We can go directly here. Sine will be, or B will be this. So what is this? 2.32 times the sine of 37 divided by sine 115. 1.541 is what I'm getting. These are miles again. But again, that's not the end of the problem, because what we actually wanted was the altitude of the balloon, or the height. So since we now know B, now we can use our right triangle tricks. So 1.514 or 541. That's B. So focusing on this right triangle here that the altitude forms, we know that the sine of the 28-degree angle will equal the height divided by the hypotenuse, the 1.541. So again, we find that our height is just this answer times the sine of 28. So if you use the full decimal expansion of this value here, then you get 0.723 in other miles. And if you don't like giving your answer as 0.723, if you don't like giving your answer as less than a mile, then you could convert miles to feet. The conversion factor is what? 5,280 feet in a mile, but there's no reason to do that. It doesn't say to. Nah, that feels stupid. We wouldn't do that. We'll just leave it as a decimal. But that's it. We're done with 40 now. We can move on. Okay, on to the next one. Okay, so this one's slightly different because this time we have two angles and a side, but the side is not between them. So this is side angle angle, or angle angle side. So if we read it, we've got the two lighthouses, lighthouse A, lighthouse B. They're 20 miles apart. That's all labeled. It says a ship's captain at S measures ASB to be 33. That's labeled. A radio operator at B measures ABS to be 52. So find the distance from the ship to each lighthouse. Okay, so that means the distance opposite from B, and we'll call it B. And the distance opposite from A, we'll call it A. Still don't love that. Doesn't feel right to me. But okay, so how do we do this? Well, B would be the easier one to find, I suppose, because when you've got angle, side, you know that your side is opposite from one of your angles. So we've already got that known pair of opposite parts. Then we've got the 52, which is opposite from B. So we see that we can get right to work solving for B, because we'll set up our ratio where the sine of something is getting divided by something. And we set that equal to the sine of something getting divided by something. So if you grab the green parts, then the 52 is known to us and B is our variable. And if you grab the orange parts, then we know both the 33 and the 20. So you're just solving from here now by cross multiplication. So 20 sine 52 is going to equal B times the sine of 33. So I'm going to divide by sine 33. And I'll get what I get. So 20 sine 52 divided by sine 33 is 28.937. And we're talking miles. So now for the next one, we want this side, but we don't have this angle, but we can go ahead and find that angle easily. So we know that to find the measure of angle A, we just do 180 minus the sum of the other two angles. So that's a 95-degree angle. And now that we know that it's 95, we can solve. So we'll take the same orange ratio from before, sine of 33 over 20. And we'll set it equal to our new lavender ratio, which will be the sine of 95 over A. Cross multiply, A is going to equal 20 sine 95 divided by sine 33. So I'm getting 36.582. And that's it for 45. Moving on. Oh, good, we're done. Happy, great. All right, that's it for law of sine stuff. So let me know if you have any questions.